Welcome to Chapter 11, Public Key Infrastructure and Encryption. Encryption is a big part of access control. It's a big part in everything you do on the internet. You're going to have to take a class probably in cryptology, which will get in a lot more depth. But we're going to give you a good overview of how it works, how we use it, and why it's so important. So we'll start with the introduction. Encryption is part of your everyday life. So if you do anything on the website, you use it on the internet. Each time you access secure websites, conduct a transaction at an ATM, you check your email, encryption lurks behind the scenes, providing the secure transmission of information. Encryption relies on the use of encryption keys to ensure that information is only readable by the intended recipient. Distributing and managing these keys is one of the trickiest parts of implementing an encryption system, and many encryption system approaches the public key infrastructure, PKI, fills that role. So what are we going to be looking at in this week? Public key infrastructure, how integrity, confidentiality, authentication, and non-repudiation are ensured within public key instruction. We'll see what it's not, how businesses use cryptology, how certificate authorities issues, manages, and revoke digital certificates, what risk associated with PKI, and best practices for it. So we're going to do give a good overview of how it works. So public key infrastructure, PKI. It's an important mechanism for businesses and e-commerce transactions. It provides a community of trust. Through this trust, people are able to browse the web more securely, send secure emails, and download software. PKI does not solve security issues, but it does make all software safe as long as it's used websites. And it doesn't have malware embedded. However, it does provide infrastructure to make the internet safer and provides a level of security. So public key PKI is different than public key cryptology and PKI are indifferent. Public key cryptology is also referred to as asymmetric cryptology. PKI infrastructure is secure distribution of public keys that is used. And we'll go over what that actually means in a few minutes. So what is the public key infrastructure? It's the framework that consists of programs, procedures, security, policies, and it uses the standard of X.509 standard for digital certificates, which we'll get into. But components, the public key infrastructure is made up of several components: the certificate authority, registration authority, certificate server, certificate repository, certificate validation, key recovery service, time server, and signing service. So all these parts make up what public key infrastructure is. It's not just an application we put on, but it has all these different parts. So the certificate of authority is an entity, normally a trusted third party, that issues the digital certificates for identity. And basically it just means that they've verified that this website and person is real. So it helps keep everything nice and safe. The registration authority is responsible for the registration of initial authentications of users who issue certificates. The certificate server is the machine or server responsible for issuing the digital certificates based on information by that. The repository is just a database. The validation is the process of determining that, yes, this website is good, and so on. So that's kind of how it all comes together. So encryption and cryptology, PKI provides the capability to distribute public encryption keys while keeping decrypted keys private. So what is encryption? Encryption is the process of applying an algorithm to plain text, resulting in ciphertext. So this takes a Word document, converts it so no one can read it. That's all it really does, and it's run through an algorithm. So the crypto system is a combination of hardware, software that provides encryptions and de-encryption. So the encryption system is made up of encryption algorithms, keys, softwares, protocols, and the algorithms determine how the encryption and de-encryption will take place. So this is all that will do for us. Symmetric encryption. Symmetric algorithms use share keys for encrypting and decrypting. Both sender and receiver use the same key. So just think of it as when you have your house, you have a set of keys for you and one for your friend. Well, you use the same key to get into that house. It's the same concept. You both have the same key, so you have that. So the symmetric key system encrypts and decrypts information with the same key. Symmetric requires a secure method to secure that key, keep the key secret. And each pairs of users require that. So for me and you to share data, I can send you the key, you have it, and I have it. It's nice and simple. And that's how it works. Now the asymmetric encryption uses a pair of keys, related keys, a public key and private key. For the encryption key and decryption, a public key can be known to everyone. The private key is known by the end user or the owner. So if you want to think of it this way, if you have an office building, and so I have my key to my office that will only open my office. Well, guess what? The janitor has a key that will open everyone's office. So it kind of works on that concept. The janitor has the key for everyone, so he can get into the offices to clean them, but you can still only get into your one key. So it's a master key, if you want, that would unlock it. But it works the same way. It sends it through an algorithm that allows us to encrypt basic data and allows us to do it. Now the asymmetric, let's see, what is this? Different group sizes. So the number of keys needed. So if I have a symmetric key, which means I have to share that key. If I have 100,000 people, if I have 2 people in the group, we have 2 keys. If I have 3 people in the group, we have 3 keys. If I have 5 people in the group, well, now I have 10 keys. If I have 10 people, 45 keys. Where the asymmetric, for 2 people, we'd have 4 keys. For 3, we'd have 6. So in the end, we have a lot less keys we need to get going. So it helps us do that. So now, business is a requirement for cryptology. For multiple uses within the organization. Some of these include internal data, external data. And remember, when data is encrypted, no one can read it with the naked eye without having that algorithm or key to break it apart. So some of the things that allow us to encrypt data, ensure data integrity, right? Because if you can't read it, you can't change it. Ensure secure collaboration between entities inside and outside the organization. Ensuring secure cloud computing. Providing secure transactions with consumers. Ensuring software and data integrity means that the software is secure and being developed. If you're storing stuff on the cloud, you want to keep it encrypted. Now this gets us into the digital certificates. The digital certificate in key management is used by individuals, users, servers, devices, and third parties with known this. And especially this becomes really important with the Internet of Things. Digital certificates, it means that that third party verified that this company is using the correct encryption methods. So we can have different versions of the certificate, unique serial numbers, algorithms, so all these things are part of that. Registration or authority verifies that the identity of the individual initiated certificate provides with the CA. So domain validation, organization validation, extended validation. It will also help us with key generation, key distribution, key storage, key usage, key recovery, and key things. So these are some of the different things. So what's the difference between symmetric and versus asymmetric algorithms? Symmetric and asymmetric encryption algorithms varied in many ways. Just learned about a few ways can be implemented, but a major difference outside of the ones we've already looked at is asymmetric cryptology requires longer keys in order to achieve the same level of security through symmetric. But the 2 people who invented this was Whitfield Diffie and Martin Hellman, who did created the asymmetric cryptology in 1976, and this allows us to have this that we have. So if it's just me and you sharing data, or symmetric would be easy. But if I'm sharing it with the class, everyone would have their own key, and I would have the master. So asymmetric would work better. So it allows us to work in that information. Ensuring integrity, confidentiality, authentication, and non-repudiation, PKI system uses symmetric and asymmetric encryption algorithms and digital certificates to provide security for multiple applications. Confidentiality ensures that only the intended recipient can read the message. Integrity ensures that only the recipient of the message in certain things received it. Authentication allows someone to prove his or her identity using asymmetric. And non-repudiation ensures that the objective third party can verify that the message came and purported sender and was not forged. Now, we're going to talk about digital signatures. Now, digital signatures use something called a hash. Now, when we sign something, we want to verify that it doesn't get changed. In today's documents, if they're not printed out, well, we have this PDF file, but as you know, we can change PDF files. So we're going to use this thing called a digital signature that requires cryptographics hash function. And so what the hash function does is it takes that document, and instead of it being run through a different type of algorithm that allows it to say, I want a 32-bit output. So whether I type hash the word yes, it's going to be 32 bits long. If I hash the book of War and Peace, it's going to be 32 digits long. So I set my output range, and then what it does is it takes every piece of information on there, every period, every space, every letter, every white space, whatever it is, and it generates a 32-bit number. Now, they're much bigger than that nowadays, but just for an example. And then what happens is when I get that document, I can sign it, I send it back to the user, the originator, and I check that document. So it checks that hash, and it has to be exactly the same. If I just move the space or a period or change the word, well, that hash number is going to be completely different, and then it won't match, and I know that it's changed, and that, hey, I won't sign this or I won't accept the signature. So that's kind of how it's working. This is also a great tool for downloads. And usually when you download a file, what will happen before you start your download, a hash number is run. It verifies it. When you complete the download, it runs another hash and the number should check. If not, it will reprocess the download. So what is PKI? What is PKI and what it is not? PKI is the framework to build a secure infrastructure. PKI has a strong authentication mechanism, and it allows the users to do this. It provides a mechanism to ensure that what was downloaded or read has not been altered. PKI provides integrity, confidentiality, authentication, and non-repudiation, and a single framework. Let's see. It is not the answer to your security concerns. You cannot encrypt all your data and communications and assume that everything is fine. Security within the organization requires multiple layers, and PKI is just one of those layers. PKI does not provide authorization. It may authenticate, but it doesn't provide that. PKI does not guarantee that the end user is trusted. So these are just some of the things that we have to keep in mind. What are potential risks? There are multiple risks that we could have to deal with. If PKI management is mishandled, the system can fail. Managing a secure environment with multiple keys and multiple entities can be overwhelming and challenged. Risks associated with it comes in many forms. Implementation for business cryptology. This comes as part of one of the OSI transport layer, OSI in the NIC cards, 7-layer process. And it is the encryption uses the cryptograph to ensure that communication between the points of parties or authentication. Cryptology, encrypting hard drives to prevent measures, encrypting removal devices, encrypting instant messages, encrypting files, encrypting databases. These are some of the things that businesses should keep in mind. Certificate of Authorities, or CAs. This is a third party that verifies that the digital certificate implementation is done through a third party, and they will verify. They will policy authority responsible for establishing, distributing, maintaining, promoting, and enforcing these. Certificate manufacturer generates and manages this digital certificate asymmetric key pairs. Certificate user distributes these. Revocation manufacturer generates and maintains of the expired keys. Best practices: implementing a PKI use within the organization requires much thought and planning to determine how capabilities will be used. The important to understand why you need a PKI in the first place and the impact it will have. What are the business drivers that we're going to need? Are you implementing it for e-business, requiring it for integrity, confidentially? What applications might you use? What architecture might you be using? The impact will implement have on users and customers. Can the current organization infrastructure work? What are the legal policies we need to look at? Who will have the access to the system? So these are some of the things that we want to look at. So let's have a chapter summary. Basically, we discussed symmetric and asymmetric encryption algorithms and how they're used with the public key infrastructure. We looked at the risk associated with maintaining key management and certificate authorities in-house and outsourcing them. You reviewed the security services that provide through the various PKI functions and how each of them functions individually. Understand these concepts will assist you in understanding that technology. That kind of gives you an overview of what encryption does, PKI infrastructure and encryption. Thank you. Have a wonderful evening. Welcome to Chapter 12, Testing Access Control Systems. So as we know, testing is a crucial activity for any IT department because it provides assurance that the access controls and other security systems are working as designed. It also illuminates gaps in security that might not be obvious to the casual observer. By testing IT architecture thoroughly and regularly, an organization will know how secure its systems really are and what needs to be done to make sure that those systems support the organization's goals. So what are our goals for this week? Discuss the purpose of testing access control systems. Discuss the software development lifecycle. Describe the life cycle of security systems. Understand information security activities. Perform a penetration test. And then the last is that report. So the purpose of testing access control systems, like any other technology, should work as designed. Unfortunately, like other security systems, access controls are constantly under surveillance and attack. Access control systems are a tempting target because they provide keys to the kingdom, and we need to make sure we keep out the attacker from making sure that we're not getting hacked or anyone's getting into our systems. So we're going to review some of these: software design, hardware development, and penetration testing. Each of these have a place that allow us that all work together in the protecting our system. So as we talked about software design, we want to make sure that we have software design, everything is built in place, and we follow procedures to make sure that every time we do our designing software, it is following the procedures we need that meet companies' needs to ensure that the system is not going to have any flaws in it. And part of that software design is to making sure we have our software testing. The testing should be performed while it's being built to help us ensure that everything is going through correctly and that there's no flaws. Same with the hardware development. So, because we got to have the hardware that's in place to do everything. So we have to have the hardware development. And again, we want to make sure that as we're building the hardware, we're constantly testing it, making sure there's no ports left open, and that it does have the proper software to prevent any attacks on it. And then all this comes back to our penetration testing, which we'll get into more details. But basically, we usually hire a third-party company to come in and try to break into our system. And this allows us to see if there's holes that we need to look at. So some of the penetration testing is literally having someone hiring a third party that's going to break in. It usually would give us a time frame of when this attack will happen. Where I used to work, it was about over a 3-month period. They said between January and end of March, we're going to attempt to hack into your system. And we would never know if they did or not, if we didn't catch them. And then at the end of that, they'd write up their report and allow us to, we then would present it, and we'd see what holes we'd have, what we'd have to fix to make sure that this was prevented from happening again. So we're going to look at the system, the development life cycle. And this is usually when we're doing a project management. We're going to be putting in new software, new hardware, or new security systems. And we use the system development life cycle to help keep track of everything. It's a IT version of a project management. So, and we work together with the entire group. We work with the IT department. We work with security departments, developers, and we make sure that we have it. The 7 areas that are built into this, and this is also could be known as the waterfall method, but we start with planning, requirements analysis, software design, development of coding, testing and integration, release and training, and support. And then we're also going to look at something called the agile software development, and that's a little bit different in how it goes about the process. It's more integrated. It's not one than the other. And so these are some of the things that we're going to look at. So the planning stage. This is the very first part of the process. And this is where we get the stakeholders are giving us the software project or hardware project that we're trying to do. And the stakeholders have the awareness that we have to maintain our security and have everything in place. During the planning stage, high-level requirements are defined. We don't have details. It's going to take approximately 6 months, cost approximately $1 million. We kind of have an idea of what we're doing. The second stage is the requirement analysis. This is also a high-level thing, but it starts getting transformed down into some of the details. What are our deliverables? When are we going to be done with part 1, part 2, and so on? When are we going to get the users involved with authentication, authorization, and how we have that? Then we get to the software design. Once formalized requirements have been laid out, system architects and software engineers can begin to design the low-level functions that will make up the final product. At this stage, specific access controls measures are designed into the software. And we have the development. During development cycles, programmers are actually writing the code, building the hardware, doing the integration. At this point, we usually do unit testing what they build instead of waiting till the very end. We do have a testing and integration area also, and that allows us to do the integration testing to make sure it's going to work on our current systems. It's not going to have any flaws. It's going to work on the operating systems. It's going to work with the database. It's going to work over the network. And we also want to do something called load testing, what it's going to be like when we have all the users on it, and that is causing issues. So these are some of the things. Then we get into the release and support. That's the 7 stages that we usually do. So now from the security development life cycle, a little different, and it has the initiation, acquisition and development, implementation and testing, operations and maintenance, and sunset or disposal. So we're going to take a look at this. Initiation phase. During the initiation phase, the existing architecture security systems are documented and preliminary risk assessments conducted. Applicable laws and regulations are identified. The documentations and analysis done during this phase are crucial. The acquisition and development during this phase, a more complete risk assessment. So we're trying to review what we have going on. We see what we had and what do we need to make it better. We create our baseline here, because if we don't have a baseline, we don't know if we're making it any better or not. Once this is done, the security team establishes the goals that we're trying to get. We'll send out RFPs to the vendors to make sure we can get the quotes that they're going to be able to do the work in the time frame that we want. The implementation and testing, once the new systems have been purchased, it must be installed, and that's the implementation, and then we're doing the testing. And again, we're going to do the unit testing each unit, and then we also do the integration testing. Operation and maintenance. This is the longest of the phases, and this system is continuously monitored, incidents are dealt with, and the security team modifies. And the old system will either be going to be sunset or disposal. How do we get rid of this old system that's obsolete and we're no longer using it, or it's not getting upgraded? From that point of view, we have to figure out how we're going to remove it to make sure the new system's replacing it, that we don't have any open time. So we want to make sure the new system's in place before we actually bring down the old system. But we do run into difficulties where the two systems could clash. So we got to make sure we resolve that before we do the installation. So security monitoring, incident handling, and testing. Security teams regularly monitor anything that's going on. We maintain a log, day-to-day activities. We run automatic scanners, reviewing the logs to make sure nothing's happening, because having logs is a great way to detect any intrusion, but if we don't review them, it's not doing us any good. So we have that automated. Development of the test plan and scope. So what do we want to look at for when we're doing our testing? So what is the impact? What vulnerability do we have? What is our breach planning, gap analysis? The impact, what is it going to have on our test operations? Are we going to have any disruptions? Will testing being done off hours versus being done during the day? Vulnerability, are there known vulnerabilities we need to take back? And gap analysis, security concerns. Intrusive versus non-intrusive testing. Continue without interruption by the security testing. Non-intrusive test methods such as host discoveries or port scannings. Host discoveries is the process of scanning the network to find out if there's any IP addresses attached to potentially vulnerable resources such as web servers or databases. Port scanning is a technique designed to probe a network's open port. Ports that are not being used should be closed. Non-intrusive testing methods can uncover valuable information about potential vulnerabilities. Vulnerabilities assessment scanning. IT crimes are generally crimes of opportunity. Attackers look for weak networks and bypass strong ones unless resources are strengthened. So we want three types of basic vulnerabilities assessment. We have network scanners, a general purpose scanners that probes a network for a variety of widely known vulnerabilities. Port scanners, a special tool that probes open ports on a system, and web application scanner scans host web applications for known vulnerabilities. So we want to make sure we have this going on. Unauthorized access and breach attack plan. Security breaches are inevitable. Security breaches will happen. They can occur despite the best efforts to prevent them. Knowing this, incident response and remedy. So what is our incident response? The initial response to security. Cleanup. What do we need to make sure that nothing was broken? Did they create a back door? So we want to make sure of this. And now with the government laws changing, we only have a certain time frame we have to submit this. So user domain gap analysis. We focus on training the day-to-day practices and known practices. If users are required to attend an annual security workshop on a secure password creation, and then we must make sure that they follow through. Workstation domain. Because the number of workstations in an organization can be high, automated vulnerability scanners are often the most efficient way to perform gap analysis in a workstation. LAN domain gap analysis focuses on the network itself, how the resources on the network are there. LAN to WAN domain. There are tools such as port scanners that come into play. So these are some of the things that we want to evaluate as we go through this. Now, we talked about remote access a few weeks ago. So these are some of the things we want to make sure that we have. Remote access domain, allowing remote access to internal resources makes it, because these are people that we want to get in, but it makes it a little harder for us to verify everything. Performing that systems penetration test. And it's usually a simulation. They're not going to hack anything, but usually we hire a third party to do this. We can do it internally if we have the proper tools, but usually it's just an easier way to do it. So the penetration test will have a plan. They'll sit down and meet with management. What information will be gathered. If they do get in, making sure that they do not get in and actually take any information that should not be. Vulnerability protection, penetration attempts, analysis reporting, and cleanup. So these are the things that they're going to look at. If access control policies are followed, every organization should have policies and standards for access control. Simply having a standard is not good enough. We're making sure we have that. A good penetration test attempts to uncover inconsistencies and exploits them. Access of security baselines definition is being used. Some countermeasures. Preparing the final report. After the third party, or even whether it's internal, we want to make sure we have our deliverables of what the penetration. And in that, the final report's going to tell us what they actually did, when did they do it, how did they do it, what did they find, good or bad. And if they found it bad, then we should come up with the identity gaps and risks that were exposed. We want to make sure that they describe what the activities were and make sure that we can follow up and make sure that it's there and close those things, close those areas of weakness. Testing in various forms is an important tool to identify vulnerabilities and security gaps in the organization IT infrastructure. Ideally, a testing plan should include both intrusive and non-intrusive test methods, as each will provide a different view of the infrastructure. For the protection of the testers, intrusive tests should be conducted only with the fully approved of upper management as well as legal documentation. Once security testing is complete, a detailed report of the tester's finding as well as recommendations invaluable guide for improving overall security.